Hi everyone, in a previous video I introduced my new 4-post lift. Well, not new, but I bought it on the used market and it's about 10 years old, but it's new to me. Well, one day I was operating the lift and I was raising the car up and all of a sudden I hear a loud pop and smoke coming off of the left side of the motor under an ear similar to this side, which is the run capacitor. So I wasn't sure what happened, but since it's 10 years old, I went ahead and just replaced it with a similar one. Put it back in, started raising the car up again. 5 to 10 seconds after running the motor, boom, the second replacement one blew up. So I realized that it wasn't just a run cap problem, it was something else outside of that causing that. So I decided to make this video that covers not only a basic understanding of how single-phase AC motors work and how these capacitors are wired into it, but also how to troubleshoot common issues, and not just the run capacitor, but we'll cover other topics too. I'm also going to take apart this hydraulic unit so you can see the inside of the motor and how this kind of comes apart. So if you're having issues with an AC motor, whether it's running a hydraulic unit like this or maybe a compressor or another piece of shop equipment, stay tuned and maybe I can help you out with it. Okay, well, before we get into the troubleshooting, let me give you a little bit about this lift. If you didn't watch my previous video, it is a kind of bottom of the barrel Chinese unbranded manufacturer. It's made by Duro Manufacturing and it's branded typically as like Tuxedo or Iron Horse or various different brandings. So it's fairly a generic manufactured machine here. The lift motor worked just fine, but like I said, after me using it for probably more than it's ever been used before, then I started developing a problem, which was the run capacitor, which was under this ear on the left side of the motor, kept popping on me. And just so you can see, it's not just it went out of spec. I mean, it is utter disaster. It blew up. So that's the run capacitor, and the start capacitor is under this ear, and I've marked it, the ratings on it. So before we start into the troubleshooting and disassembly of this unit, I'm going to flash up a diagram and just kind of basically give you an overview of the wiring of this thing. I'm going to credit the YouTube channel for this because I couldn't find anything good online, but I actually found a good YouTube video that had an explanation of these single-phase AC motors. The way that this goes is out of your breaker you have a hot line, and this is just talking about 110 volt, which is what this is. They have it going into a overload protection circuit or maybe a GFI or something. That's hilarious. That this unbranded Chinese manufacturer, they care very little about their customer safety or product quality. So we of course don't have that overload protection. But what we do have that's not on the diagram is a momentary contact switch, which actually gives the voltage to the motor so you can actuate it with a switch. So just replace that switch in the diagram. Then out of the switch, the hot goes to one side of the capacitor. It shows it as the starting capacitor, and then out of that terminal is connected to the run capacitor. So in reality, you've got two wires like this plugging into either terminal of the capacitor, which looks like this. You typically will have two terminals. Well, there's four, but they're really just two terminals. You can just hang some extra wires off of them. But this wire should be coupled to another wire on this other side. So if you're measuring continuity, one of those wires between the capacitors is continuous. Then we go out of the run capacitor and into the one side of the windings, which is the run winding. On the other side of the start capacitor, you'll see that it goes up through a centrifugal switch. And then from the centrifugal switch, it connects back to the starter winding with the run capacitor. So if you look at it, the run capacitor is always across the windings, but the starting capacitor is only across the windings when the centrifugal switch is closed. So with that high-level overview, let's start with the troubleshooting. One of the first things that I would look at if I was having an issue with the motor is possibly the start capacitor. Now, I don't understand why some motors have a start capacitor and no run capacitor, and some need both. I'm not really sure. But the start capacitor is a very common thing on most single-phase AC motors, because if you don't have it, literally when you apply voltage to the motor, it just sits there and hums. It won't spin. And so that is maybe our first troubleshooting tip is if you operate the switch and you just hear a hum from the motor, but you don't really hear it turning or anything happening, likely it's the start capacitor is either bad or out of spec. The reason for the start capacitor is for these motors, there's actually a weird effect on the phasing of the AC, where when you just apply voltage to a motor without that start capacitor, it won't actually turn. It's kind of stuck in a phase resistance. And what happens is these start capacitors, when you apply voltage with the start capacitor, what it'll do is it'll charge up the capacitor, and the capacitor will kick the motor and actually kick the phase so that the motor starts to rotate. Once it starts to rotate, then the voltage will keep it going, and then it's good to go. That's why the start capacitor is not needed for the entire run of the motor. So the run capacitor, though, on the other hand, is always tied to the motor and never gets disengaged. What I think that is, and it's usually a much lesser microfarad value, what I think it's for is for doing tiny kicks while the motor is running so that the motor runs as efficiently as possible. Okay, like I said, so if the start capacitor was bad or missing, the motor wouldn't even begin to turn over. It would just kind of make a hum and wouldn't do anything. Now, the second thing you might want to troubleshoot is, okay, well, what if you hit the switch and it doesn't just hum, it actually starts to turn, but the lift, it struggles, right? The lift just isn't coming up, right? Well, what I would look at there is just whether or not you have mechanical issues with the lift. In other words, the hydraulic arm that's under here is bound up and it can't seem to get up and going. Obviously, there could also be a hydraulic leak or anything, but you would probably notice that where the fluid would just start draining out. So in the case of the lift struggling, I would just say, look at all the mechanics of it. Take your vehicle off, try to lift it up as much as you can, and just look at all the cables. Your cables, especially on the end of it, there's a bunch of pulleys underneath here, and the cables have to be routed properly. Not only that, but when you originally set it up, your ladder stops should all be basically level to each other, so that when the lift comes up and you hear the safety stops engaging, they should all engage basically at the same time, like click, 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 click. And again, your cables should be all about the same. They should be running around the pulleys, and just make sure that it lifts up just fine. The other thing you can do to see if your motor is maybe struggling because of a mechanical issue in the lift is to look at the black power wire here. So on 110 volt, you would have one hot wire, a neutral, and a ground. So if you can get enough of this hot wire isolated out, and if you have a meter that has a clamp on it where you can get the clamp around this, then you can put it on amps and look at what it's drawing. Now, the nameplate on this motor, this is a 2.2 kilowatt motor, and it shows 20 amps. But in reality, when I was measuring this, because that's one of the things I did, is I thought maybe the run capacitor was popping because the motor was struggling, or drawing too much current. Well, I don't think that was the case, because when I ran it, with the hot inside of my ammeter, it was drawing 14 amps continuous, which is under the 20 amps that this 2 kilowatt motor can produce. And I haven't seen any binding on this. I have gone up and down on it. I haven't seen any places where it stops for a minute and then goes up, or it also, I made sure everything's plumb and level and everything is routed. So I don't think it was a problem with current draw or the motor struggling. I've also heard from I think it was a YouTuber, that another thing that could possibly go wrong on these really cheap lifts is this switch. This is a pretty chintzy switch for how much amperage is going to go through it. I've heard that one guy mentioned that when he was operating the switch, he let off of it and the lift kept going up, meaning it fused itself shut, and so he had to actually pull the plug on it to get it to stop. And then of course he had to replace the switch. So that's an obvious problem there, but I have heard about that from this type of lift. Now, as far as troubleshooting the run cap and the fact that it's popping, I have no idea what's happening. But I'll give you a hypothesis because that's the best I can do. When searching online, I couldn't find much information about run capacitors popping. You'll see stuff in like stereo electronic forums and stuff like that because there's a lot of capacitors and power amplifiers and things like that. And they'll say, what makes a capacitor pop is voltage, over voltage, or potentially hot temperatures and things like that. Well, I mean, the capacitor I had was the original one, and I think it's rated at 300 volts. From what I know, when you're replacing these capacitors, even though it's a 115 volt setup, your capacitors that are running should have a higher voltage by like maybe 40 or 50%. So it's typical to put like 250 or 300 volt capacitors in a 110 volt lift, and on maybe a 220 lift you would put like a 400 volt capacitor. Well, so I shouldn't have had a voltage problem. But what I was noticing is, I showed you when I was putting my ammeter on there to measure current, and I saw a reasonable amount of current, 14 amps being drawn, but then I would see spikes, and then like when the capacitor blew, and I would occasionally get my breaker to trip. What I think was actually happening, I think that the motor has a short somewhere in the windings, and when that short would happen, over and over again, eventually I think it either built up current or voltage, and I think that's what blew the run cap. And that's why the starting cap didn't have that problem, because the centrifugal switch had already disengaged it from the circuit. So that's my guess, and that's what I'm going with. So what do you do if you have motor winding problems? Well, the cheapest solution may be to find another motor like this, maybe a salvage motor, but the problem is, like when we disassemble it, I'll show you that the stator inside there is very specific designed with an end on it for this hydraulic pump here. So you can't just buy any, electric motor with any shaft on the end of it. Well, my fix for my particular issue was to purchase a whole new unit. Well, here's the new unit that I bought, and this was from Vevor. You probably have heard of that. I'll have a link in the description to this new power unit. If you come to the conclusion that you have to replace the unit, here are a couple tips on what you need to look for in a replacement unit. So first off, what you want to do, and by the way, Vevor sells the same one in a 220 and a 110 version. But again, when I took my nameplate off, I'm looking at some of these values, like the RPM is 3450. It's a 2.5 horsepower motor. It's and then the PSI and things like that. But the other big thing is the tank on it has to match, right? Because you have a hydraulic cylinder that's expecting a certain amount of fluid, and this one happens to be the 10 quart or 10 liter. Quart and liters are about the same. They also make 6 liter, 8 liter, 10, 12, probably a 20 and higher. So you need to match the liters that are in this tank to the one you currently have. But the motor, I'm just basically looking at to say, this one has a 2.2 kilowatt motor. It's 3 horsepower, so it's a little bit higher horsepower than the one I have. Around the same RPM, it's around 3,400 RPM. This one says 3,450, and everything else. So that's all you have to match up. But here's the big distinction though. This is a 220, and this is the second reason why I bought it, is because this operates on 220, which means I don't have to worry about running it on a 110 volt circuit on a 20 amp outlet and it drawing somewhere around 14 or 15 amps. Instead, I can run it at a 220 and same 2.2 kilowatt motor, but it's half the amperage. So it's rated at 10 amps, but likely it's only going to draw around 7 amps. So that's a lot safer, I think, in terms of my wiring and everything and where I plug it in at, than the 110 volt version of this. So now that I've done my troubleshooting and I've come up with my fix, let's go ahead and just take this thing apart, and that way you can kind of see what the insides look like, and you'll know how to kind of take it apart. I've taken this off, obviously it just bolts, the whole motor bolts onto there, and I do know that these bolts up here go all the way through. They're like a threaded rod they bolt into here, which is then fused into this in some way. Maybe it's bolted from the inside, the actual hydraulic thing. The tank itself, I think it's just this hose clamp, so we're going to have to take that off because there's almost 2.5 gallons of hydraulic fluid in here. I'm going to go ahead and try to take this down to lighten the weight. All right, as you can imagine, it's not just a hose clamp holding it up. There's also this big O-ring, and you really have to bear hug it and pull it down. All right, so I got that off, and that's all just kind of dripping into the container there. So I'll kind of let it finish dripping there, wipe it down, and then we'll go ahead and take these bolts off. I've already got, just so you can see, they're threaded all the way through and into the bottom piece here, which is then fused to this pump somehow. I don't know how, but we'll take all 4 of those bolts off here, and when you do that, be careful because then this will separate right here, and I'll show you that. Okay, well here is the unit. As you can see, the stator comes out with it. So the motor's pretty much just the windings inside there. So what I'm going to do now is I'm going to pull the stator arm out of here. There's bearings on either side, and you just pull it out. And there you go. There's the hydraulic unit. I'm just going to disassemble the actual hydraulic hose that's going into the lift. But there's the stator arm, and what you can see here, one of the other things I didn't mention with debugging was I thought maybe if the centrifugal switch was bad, maybe what it could cause the run capacitor to explode is if this was bad and the starting capacitor stayed in the circuit the entire time. It turned out that was not it, and I don't even know if that would even cause the run capacitor to blow, so it probably would just cause it to run weird. But this is what it looks like, and when you're troubleshooting this, the first thing you need to do is notice there's a black, this is a plastic plate up by the bearing here, and here's the centrifugal switch. Well, this is actually not even the switch. This is just the part that operates the switch. This thing is pressed up against these terminals up in the motor, and I'll show you that in a second. Once it starts spinning, it lifts off the terminals. So this plastic piece will lift off the terminals, and the terminals will open up. And that's what opens the circuit so that the start capacitor is no longer engaged. But what you want to do is just basically play with it. It should open up freely. If these things are welded or rusted together and you can't just open it up very well, it could be a problem with the centrifugal switch. Also, you can look at your bearings while you have it open, make sure they roll smoothly, things like that. But everything else, I mean, everything looks fine on this stator. Okay, this is a little bit of a contortion thing here, but I'm going to try to show you the actual centrifugal switch contact part. If I can get around my flashlight. What you want to look for, and this looks so clean when I took it apart, that's why I knew there wasn't a problem with the switch. These little copper bars up there, they're resting against those terminals, and when the centrifugal switch is engaged, it should push up on those, which would raise them off the terminals and close the switch. And when it lowers, it should close them onto the bottom terminals, and then it opens the circuit. Well, what you want to check for, and I wish I could show you, is just kind of push on those, make sure those aren't welded on, that they can move. And I'm gonna move it for you, even though my hand's gonna block the shot, but you'll hear it click on either side. So you want to make sure those bars aren't like welded onto those contacts. Sometimes they look like almost like distributor contacts. You can maybe sand them with a little high grit paper and clean them off, but again, that's only if you're sure that your motor's running really badly and it likely is a start capacitor being left in the circuit. But other than that, I don't think it will cause like the problems that I'm having. Well, now that we've done troubleshooting and taking apart of the old motor, let's go ahead and get this guy installed. I'm probably gonna have to do it off camera because it's gonna be, you know, all my arms and legs and stuff are gonna be involved here. But basically what I'm gonna do is hook up the hydraulics back up. I'll have to figure out whether I need to do adapters or fittings to get it from whatever I have there to this. And then the wiring. Now, I've already taken the liberty of running a new 220 line. I tapped off my workshop where the compressor is running, conduit, try to do it as neatly as possible. And I've got a box up there with an Armor Light whip, and I don't have the end on it yet, but what my plan is to do is to just run that, take off this gland nut here and run my Armor Light whip right into that. So that's how I will have my 220 circuit into there and test it out. So I'll bring you back in when I get that mounted up and ready to go. Well, there it is installed, and as you can see, I obviously got it working. Let me show you what I did. I first bolted it on to the post, and the flange on the back is pretty much identical to the old unit, so that was no problem. Then, of course, I took my Armor Light whip from the sealing box, routed it directly into this box here, and plugged it into a couple terminals in here. I just pulled those stub wires out and replaced that. Then I hooked up my hydraulic line. It came with an extra fitting that I had to install, which on mine had the compression type fitting. So all I had to do was replace that fitting, and my line went on just fine. Then I put some new hydraulic oil into it. I went ahead and got the best deal I found is Tractor Supply sells this ISO 46 hydraulic oil. That's a 5-gallon bucket for $50. That's probably the best deal I could find around here. So that'll give me 2 full changes. I measured it out, put it all in there. Pretty much 10 quarts goes right up to here. This tank's barely large enough to fit it. So there is a dipstick on this thing, but pretty much to get it to 10 quarts, you can pretty much dip your finger in, and if you don't feel oil right about here, you don't have enough in there. Once I got the new oil in and everything hooked up, I took this plug out and I hit the button on the motor and ran it for a couple seconds. When this thing is dry, it kind of shakes a bit and runs a bit rough, but after a couple seconds, it started spraying out and I caught it in a cup. And then I knew I had at least the dipstick assembly primed up with oil. So then I put that plug back in. If I didn't do that, I would have introduced a lot of air into the system. You're going to get a little air in the system when you unplug the hose and things like that, but I at least wanted to bleed out the dip tube so that I didn't introduce too much air. So I took the vehicle off, I ran the lift all the way up, and the hydraulics, so the hydraulics got all in, and then I put it all the way down, which bled out. And when I did that the first time, I loosened the cap here just in case any bubbles or something had to escape, but that pretty much bleeds it all the way out when you put it all the way up and lower it back down. And then after that, we're good to go. Then I put the van back up, and as you can see, I got it halfway up on there, and so far I've done the lift up and down a few times, and it seems to work just fine. It doesn't struggle, and yeah, I'm pretty happy with that. So for the old one, I guess it's junk. I'm going to part out whatever good things I can get out of it. Maybe sell little pieces of it for people that need it. Not only is this a replacement, but I feel like it's a much better upgrade. I'll show you a picture of the inside of the box, and you can see that it is quite a bit of a quality improvement over the last one. Included in that, I read the manual, and it's even got like circuitry for like a soft start to improve the life of the motor. The switch is much more high quality. Everything on this is just much more high quality, including this powder-coated steel tank, which doesn't seem like a big deal, but if you ever have any accidents and you hit it, I'd rather it be steel than plastic. And just the fact that I can run it now and my lights don't dim, and obviously I don't have a capacitor blowing up, and everything runs really nice and smooth. So that wraps up the video, and I'm glad I got this thing not only replaced, but also upgraded to a better unit that I think will be more reliable in the long run. Time will tell. But if you have any comments, maybe I you have issues that I didn't address, or maybe you have some comments on how I did the troubleshooting or anything else you'd like to share, please do so. And until the next video, I'll talk to you later.